So we're going to be looking at the properties of exponents over the next couple of sets of notes. The beginning that we need to look at is some vocabulary, and some of this you should already know. We've been calling this number that's in front of this variable the coefficient all year, and that's still what we're calling it. So 3 is the coefficient. And the 5 is the exponent. Again, that's a word we've used this year. The one that is new. This thing, in this case it's a variable, but it's not always. The thing that is being raised to an exponent, in this case the x, is called the base. The base is not always a variable. 3 to the 5th power, 3 is the base, 5 is the exponent. And either there is no coefficient, or I could think of a 1 out in front of here, but we don't typically think of a coefficient of a number. So you need to know those words because they're going to be used frequently over the course of this unit. When you are dealing with the things in this unit, the more you can think about what something means, the easier it is to understand why the properties are what they are. So what does 4x squared mean? Well, you know that to square something means to multiply it by itself. So this is 4 times x times x. 2x cubed means 2 with 3 x's multiplied together. That's x to the 3rd power. So using the definition of an exponent, we can get these. So what this means is really to take 4 times 2, and then I would multiply these 5 x's out, which is going to give me 8x to the 5th power. Now notice what ended up happening was the 4 and the 2, the coefficients got multiplied together, but I ended up with 5 x's. The typical thing that people might say is there's multiplication, so I'm going to multiply the 2 and the 3 together, and there will be 6 x's. If you think about expanding it out, though, you see that there are only 5, which means when I multiply two things with the same base, I add the exponents. Again, 2 here is the base, it's not the exponent. So, if I think about what this means, I would have 2 2's here and 4 2's here, and I'm not normally going to expand this out. I would end up with 6 2's. So the work that you're required to show, you aren't required to show the expansion. I don't need to see the expansion. If you want to put it down in addition to the required work, that's okay. But the required work is to say, well, the property of exponents says if these both have a base of 2, then when I multiply them together, I'm going to add the exponents, which is going to end up being 2 to the 6th power. And because this is something you can calculate in your calculator, throw it in there and get an answer of 64. Now we're going to do B and E back to back. So I'm going to kind of switch around a little bit in here. My base here is -1. So my base is still -1. -1 to the 3rd times -1 to the 5th. That means I add those exponents, 3 plus 5. Because I would have 3 -1's here if I expanded it out, and 5 here, for a total of 8 -1's. The be careful part is to remember the parentheses. If you do not put the parentheses around this, and you put it in your calculator, if your calculator is bright, you will get the wrong answer. To raise -1 to the 8th power would give you an answer of +1. The reason it works that way, if you think about what it means, it would be 8 -1's multiplied together. And let me get these out. You guys know a negative times a negative is a positive. So those two -1's multiplied together is +1. And those two would give me +1. And those two would give me +1, and those two would give me +1. Then when I multiply all those positive ones together, I get 1. So if I have an even number of negatives that I'm multiplying together, my answer is positive. If you do not put the parentheses around it, it means this instead. This is not -4 squared. This means the opposite of 4 squared. So if you put this into a smart calculator, which most of your calculators are smart, it's not going to take -4 and multiply it by -4 to get +16. It's going to say this means the opposite of whatever 4 squared is. Well, 4 squared is 16, and the opposite of that is -16. Most of the time, we want to take a negative number and raise it to a power. So most of the time, we want to have that negative number in parentheses. When you get to these products, again, the 2 times the -3, the coefficients multiplied together, And then I have 4x's here, 3 more x's here, so when I multiply them together, I'd have 4 plus 3 x's. Yes, you have to show that addition work. And I only have y in one place, so it's still just a y. I end up with negative 6 x to the 7th y for my final answer. This is sort of a combination problem. One thing to notice is I have 3 coefficients, 3, negative 2, and this is the same thing as negative 1 a cubed c. So my coefficients, I'm going to multiply 3 by negative 2 by negative 1, and yes, I'm going to show this work. If I think about multiplying these together, I have 4 a's here, 1 more a here, 3 more a's here, so I'd have 4 plus 1 plus 3 a's multiplied together. I just have a b to the 3rd power, I'm not multiplying by any more b's, and a c to the 1st power, not multiplying by any more c's. So I end up with positive 6, a to the 8th, b to the 3rd, c for my final answer. The next one is a power to a power property. Again, if we stop and think about what this means, what it means to cube something, the definition of what it means to cube something is to take it and multiply it by itself and multiply it by itself again. Well, part of that, if you think about it, is a 4 times 4 times 4, which is 4 to the 3rd power, which is 64. And then I would have 2 x's, 2 more x's, 2 more x's, which is 6 x's. And the way I'm going to get that 6 out of there is to say, oh, that's the same thing as x to the 2 times 3 power. I'd have 2 of them there, 2 of them there, 2 of them there for 6 of them. So I get 64x to the 6th power, which means when I raise a power to a power, I multiply the exponents. And I am multiplying the 3 also by the exponent of 1 on the 4. We just don't have to show that. So to simplify this, again, what it would mean is I have a 4 squared times itself again. I'd end up with 3 different 4 squareds. So I'd end up with 6 4s all multiplied together. So 4 to the 2 times 3 power is the work you have to show, which becomes 4 to the 6th power, which is 4,096 for a final answer. Notice in G, the 3 is not being raised to the 4th power. Only the things inside parentheses are. So the 3 stays a 3. This would be 5y to the 4th times 5y to the 4th times 5y to the 4th times 5y to the 4th. Well, part of that is a 5 times 5 times 5 times 5, so 5 to the 4th power. And then I'd have 4 y's and 4 more y's and 4 more y's and 4 more y's, which is 16 y's, but you have to show me how you get that. So 5 to the 4th power is 625, and then y to the 4 times 4 is y to the 16th. And then last but not least, 3 times 625 is 1,875, and bring down my y to the 16th power. That is my simplified answer. Again, the coefficient here is negative 1, but notice I'm not just going to take 3 times negative 1, because this is being squared. What this really means is I've got a 3a squared b to the 5th times another one. It's going to take a little bit to write this out. And then I have 4 of these. So 4, negative 1, a to the 4th b cubed, negative 1, a to the 4th b cubed, that's 2 of them. I need 2 more of them. And another one. So I have 2 of these multiplied together and 4 of these. Yet to show that work, to get rid of these parentheses in the first place, I notice I have a 3 times 3, so I have a 3 squared. I would have 2 a's here and 2 a's here for 4 a's, 5 b's here, 5 b's here for 10 b's. The way I'm going to get those 4 a's and 10 b's is to take a to the 2 times 2 power and b to the 5 times 2 power. Using the same work here, I'm going to have a negative 1 to the 4th power, an a to the 4 times 4, and a b to the 3 times 4. Simplifying that down, 3 squared is 9. Negative 1 to the 4th power is positive 1. So 9 times 1. This is going to be an a to the 4th, but this is going to be an a to the 16th. A to the 4th times a to the 16th. 4 a's over here, 16 over here. That's a total of 20 a's. I have 10 b's here, and I have 12 b's here, so I have 22 b's when I'm done, but I do need to show this work. So 9a to the 20th, b to the 22nd. Be careful and show these work steps that are required.